Break this lesson up into easy, medium, and hard equations that we're going to solve together. Some will solve together, some will solve on your own. Okay, so we'll start with the simple or the easy equations that we'll got here. Okay, so we'll call these the simple ones. Now remember that we have a few rules that we are working with logarithms, right? Basically, we know that if a to the x equals a to the y, then what can we say? Then x equals y, right? We could say that. We can also say this. If log base a of x equals log base a of y, then what can we say?
We can say that x and y.
Then x is equal to y, right? So we can use that property a lot. So those are kind of off to the side. We're going to use those a lot. So let's start with a little easy one here. If we did 2 to the x is equal to 32, could we solve this equation for x? And of course we could. This is pretty simple because they have a base in which each one's a factor of the other. So what I mean by that is like 2 to the x equals 2 to the what would give you 32? 5, right? Very good. So that means that if 2 to the x equals 2 to the 5, then x has to equal 5. No big deal. What do you guys think about that one? That exact one was on the quiz? Oh, well, there you go. You guys got it. How about this one? How about the natural log of x minus the natural log of 3 equals 0? All right, well, we can treat these as individual pieces. And what I mean by that is individual terms. So the natural log of x could equal the natural log of 3 if I just move it to the other side. Right? So far, so good? Is that easy enough to get? Okay, so now we're going to use the fact that a natural log is a log with a base of what? So I could really say that this is just log base e of x equals log base e of 3. Now, why would I do that? Yeah, because to show you that it's a logarithm with the base is the same. So therefore, just like Connor said, x has to equal 3. Right? No big deal there, right? Pretty straightforward? Okay, let's try another simple one. What about this one? What if e to the x is equal to 7? E to the x is equal to 7. So is this an exponential equation or a log equation?
Exponential.
It's an exponential, right? Could you change it to a log equation?
Yeah.
Yeah, what would it be? Log base e of 7 equals x. Well, what do we call log with the base of e?
Natural log.
Yeah, so the natural log of 7 equals x. Oh, look, there it is. How cool is that? You even realize you solved that one. Awesome, huh? Whoa, crazy, right? Okay. Last one for these simple ones. What if we did this? How about the natural log of x equals -3? The natural log of x equals -3. Now, we can't just divide by natural log because we have to take the natural log of something. So we have to do something else, right? Any thoughts or ideas with this one? Yeah.
Wouldn't it be like a log e to the negative third part?
Yeah, so this is a log with a base of e. Log base e of x equals -3. And then, can we change this to an exponential?
Yeah.
Check it out. So e to the -3 must equal x. And that would be our answer for that one. All right, so this one, a little bit more challenging. We have e to the -x squared equals e to the -3x minus 4. Only a little more challenging because of the way it looks. Right?
Yeah.
Yeah, what do you see, Megan? What do you see?
I see
Yep.
negative x squared
Yep.
equals -3x minus 4.
That is exactly right. So it only looks scary, right? Now we have a quadratic. So 0 equals x squared minus 3x minus a 4. We're looking really good here. So 0 must be, ooh, can this factor?
Yes.
Sure can. What do we get? X minus a 4 and an x plus a 1. Awesome. That means that x plus 1 is 0 or x minus 4 is 0. So x could either be -1 in this case or x could be 4. And look, turns out both of those actually work well for us. Okay? One more in this category for the mediums. Call this example B. What if I have 3 times 2 to the x equals 42?
Divide by 3.
Megan says divide by 3. I think it's a great idea. Let's try and isolate that x, right? So let's divide by 3. So 2
It's 12.
to the x equals 42 divided by 3.
No, 14.
14. Very good. Very, very good. Okay, now, so 2 to the what gives you back a 14? No, it's a positive one. We could do this one. 2 to the what gives you 14?
Is it log?
It's gonna be between.
It'll be between what? 3 and 4, because 2 cubed is 8, and 2 to the 4th is 16. So it would be closer to 4, right? Okay, so 3.8 was our guess.
3.65.
How do we go about getting it, everybody? No. Well, eventually, yes. We're going to use the change of base formula, right? Change of base formula. The reason we're using this, you guys, is because, remember, we know this is true. 2 to the log base 2 of 14. That would give us 14, huh? Because our 2's cancel, right? So we need to evaluate log base 2 of 14. So we use a change of base formula. That gives us log 14 divided by log 2. Now, if you have a fancy calculator, you just do math alpha math, however you want to get there. So for us, here's the deal, though. I want to turn this on, clearly out. I want log 14 divided by log 2. And you guys guessed somewhere between 3 and 4, but closer to 4. And check it out. You guys are totally right. 3.81. Nice job. So I'm getting 3.81 roughly. Whew, there we go. 2 times 3 to the 2x minus 5 minus 4 equals 11. All right. Looks challenging. We got a lot of steps involved here, but it's not that bad. What's the very first thing we should do? Steven? Yeah, add 4 to each side. So how about 2? 3 to the 2x minus 5 equals, what is that, 15? Yeah?
Yeah.
Okay, good. Now, thoughts, questions. What should we do?
Divide 2 by each.
Divide 2 by each side. Very good. Divide 2, divide 2. So I'm looking like 3 to the 2x minus 5 is equal to 7.5. Because 15 over 2 is 7.5. Okay, now what should we do? We have an exponential equation, right? If we have an exponential equation, can we use the definition of logs to help us rewrite this in a certain way?
Yeah.
What can we say?
Log
Log base 3. Very good. Awesome.
of 7.5.
So log base 3 of 7.5 has to equal 2x minus 5. Beautiful. Awesome, you guys. Very, very good. The goal here is to solve for what? Solve for x. So we're going to say log base 3 of 7.5 plus 5 equals 2x. Very good. Yeah? Okay. Finally, we want to divide by 2 on both sides of my equation to get x is equal to log base 3 of 7.5 plus 5 divided by 2. Yeah, so that's the exact answer right there. But we're gonna put this into our calculator and get an answer, and we should get something like 3.4 when we're all said and done. So let's learn how to do this, okay? Well, first of all, log base 3 of 7.5, you need to change the base formula for that, right? So I'm gonna go log 7.5 divided by log 3. Okay, that gives me that answer. Then I need to add 5 because it says plus 5, so I do that. And then finally, divide by 2. And I'm getting 3.417. Is that what you guys are getting? All right, so I don't want you to get hung up on the calculator mistake once you do all the hard work to get there. So we're getting roughly 417 and some change, okay? Okay, you try within your groups. Let's do e to the x plus 5 equals 60. Could you round this to 4 decimal places? 4 decimal places. Ready, set, go. Okay, so you should have got like something like 4.0073. Yeah? Very good? Okay, awesome. Okay, so e to the 2x minus 3 times e to the x plus 2 equals 0. This is an interesting problem, okay? There are 2 approaches that I have seen. One of them is to do a substitution, and the other one is to just do a straight factoring. So with you guys, I'm going to try the straight factoring approach to see if you can see it, okay? So this actually is a quadratic. It has 3 terms. It's something that's squared, right? So see if you can follow this logic right here, all right? Again, this is still equal to 0. Would you guys agree that e to the 2x can be broken up into e to the x times e to the x? Now convince yourself that that's true because when you are multiplying bases, you add their exponents. So x plus x, 2x. That's exactly what it says right up there. Okay?
It's not EX, X squared.
No, because we're multiplying e to the x times e to the x. That's e to the 2x. Okay? So far, so good? Okay, now, let's take a look at the number 2. 2 and 1. Minus and a minus. Very good. Minus and a minus. I'm glad that you guys see it. Not that bad, right? But you wouldn't have thought of it. It's interesting, right? Okay, so then, therefore, we're going to do the zero product property. It says e to the x minus 1 is 0, so e to the x is equal to 1. E to the x is equal to 1. Huh. Very good. So x is equal to the natural log of 1, and we all know that to be 0. All right? Very good. On the other side, we have e to the x equals 2. E to the x equals 2, so x equals the natural log of 2, which is approximately 0.693 when you run it through the calculator. All right, this box here covers something called extraneous solutions. Now, an extraneous solution is a solution that is produced through the algebra of the problem when you're solving it, but it doesn't quite fit in with the actual form of what you're solving in terms of domain. So I'll talk about that in just a sec, all right? So, but before we get there, we're going to solve this like we normally would. I see an addition sign here, right? So how can I bring those two together? Yes, sir. Very good. So log base 10 of 5x times x minus 1 is equal to 2. So far, so good. Step number 1 done. Yeah? You following the process? Okay, what am I going to do next? What's my... I'm going to distribute. Okay, all right, I can do that. Log base 10 of that 5x squared minus 5x. Yeah?
5x.
Equals 2. Okay, I'm with you on that one. Then what am I going to do? No, not subtract 2. Yes, very good. Put it in exponential form. Now, what's my base here? 10. Yes, I can. There you go. No. We don't want to put the minus from the other side. We're going to exponentiate this, okay? We're going to turn it into, we're going to turn it into an exponential equation. My base, remember, everybody, is 10. So we're going to say 10 to the power of 2 has to give me back 5x squared minus 5x. Yeah?
Yes.
Okay, good. So let's write that down. 10 to the power of 2 has to give me back 5x squared minus 5x. Can you see where we're going to go with this?
Yeah.
Very good. 0 is going to equal 5x squared minus 5x minus 100. Where'd that 100 come from? 10 squared, then move over to the other side. Very good.
Quadratic.
It is a quadratic. Can I do anything more here now?
Yes.
So, x squared minus x minus what?
25.
25.
20.
I think it's 20, not 25. 20. Okay. All right. That is factorable. Very good. So 0 equals, we can easily factor this. We are factoring kings and queens around here. Okay, 20. I need a 20 and a 1. There we go. I love you guys know this. A 5 and a 4. So a minus 5, a plus 4. Boom. So that means that x has to be negative 4. Or x has to be 5. Okay, you guys. One of these answers is called extraneous. Do you know which one it is? Okay, we're all betting on the negative one here, but can someone say why? Tommy, what do you think?
Because when you plug in, you can't have a negative number.
Very, very good. In both, my battery is running low.
It's okay. We'll just finish this next
We're almost there. We're almost there.
Don't worry, we got plenty of juice. Okay, so when you, yeah, we're back on. When you plug in a 4 right here, check out, you get this. Log negative 4 minus 1. So that really says log base 10 of negative 5. There is no number in which you can raise 10 to and get a negative 5. Remember, the domain for all log functions, we have to take whatever is inside our parentheses here, set it greater than 0. So when we get our answers down here, this one is extraneous. Therefore, the only answer that we're going to use is 5. Okay, here's the setup. The setup is this. You have 500 bucks. You get to invest that $500 at 6.75%, which is awesome, by the way. 6.75% compounded continuously. Okay?
I heard like nowadays
It's probably like
point
0.001, right? Yeah, okay. But here's the question. How long, meaning time, how long before, given given the fact that you have $500, given the fact that you have 6.75%, and given the fact that it's compounded continuously, how much time is it going to take for your investment of $500 to double? So we're going to be solving for t. Right now, I want you to take a guess, though, okay? Is it going to take 1 year, 2 years, 5 years, 10 years, 30 years? Take a guess right now. Write down your guess, okay? All right, what's the setup here? What's the original setup?
1,000.
Well, we know this. We know that A equals P E to the RT. A equals PERT, right? And why am I using this formula, ladies and gentlemen?
Continuous.
Because it's compound continuous. Very good. Now, our A value, we want that to be 2P, don't we? Oh, because we want it to double.
So 1,000.
Well, hold on a second. Here's it. Check it out, you guys. You don't even need the P. Watch. Look. You don't even need it. So this is what you have. 2 equals E to the RT. So who cares how much you start with? Isn't that crazy? Isn't that interesting?
Wait, so it would be the same for like every.
Yeah. So check this out. So then we're going to 2 equals E. What's our rate? 0.0675 times T. Oh, how do we solve this for T? No, we change it, yeah. The natural log of 2 equals 0.0675 times T. Divide by 0.0675. Divide by 0.0675. Now, we took a guess between 2 and 15 years before the video pushed play. So, natural log of 2. And I think Steven said 9 years, and I think Jack said, what, 8 years? 4 years? Okay, here we go.
I said 10.
Natural log of 2
You're a liar, man.
divided by
You're a liar.
0.0675. Check it out. How long is it going to take?
Done with you.
10.26 years. There we go.
Exactly. I was correct.
10.26 years.
Yeah, I know.